Hi everyone, welcome to another session with Harita Hive. Today we will talk about the SCP classification plugin and we will use it to classify the image. You all might be knowing about the just give me a moment. You all might be knowing about the supervised classification as well as the unsupervised classification. So what we are going to do is today we are first going to download the Sentinel-2 data, and using that data in QGIS, there is a plugin in QGIS that is called as SCP. So if you look around here, there is something called as SCP here. I will show you how to install this plugin, and after installing this plugin, how you can further do the analysis of doing a supervised as well as unsupervised classification in QGIS. Okay, so the first thing that you have to do is you have to go to Google and you have to look for the Sentinel-2 data download. Once this website opens, click on the first one. You will find the option to explore data here. Click on this explore data. A new tab about the Copernicus hub will open. You have to click on the login. Without login, you cannot actually download the data. So just log in with your credentials. If you don't have the credentials of Copernicus hub, you can register it and it is very easy to create an account. Okay, so simply just create your account and you can download the data. So after logging in, so this is how the interface will look, and if you have a certain place that you want to work on, just you can find out using this go to place tab here. Just look for the name of the place. So for example, I'm looking for a city in India, and I'm just enter the name and look for it. If your place or the location that you have searched for is not available, what you can do is you can pan and zoom into the area where the location is. Okay, so once you locate your location, that is your area of interest about which you want to do the analysis, either if you want to be very exact about your area of interest, what you can do is on the right side you will see this polygon shaped symbol. Just simply click on this. This is the option to create an area of interest. Simply click on it. Once you simply click on it, you will find the option here to select the region. So draw as I hover over it, it says draw rectangular area of interest for image download and time lapse. Simply click on it, select the region which is your area of interest. Once you have your region selected, you need on the left tab, just look for this search bar. If you want to just download the data for a single date, a particular date, then instead you can just look for the date here and you can directly download it from here. But if you are looking in a date range, so generally it is better to look for the data in a date range, right? So just click on the search button here and select Sentinel-2, as we are going to work with Sentinel-2 today. In this Sentinel-2, you can choose this level 2 product here. The level 2 product means atmospherically corrected product. So we don't actually have to do any corrections before doing analysis on this data. So it is always preferred that if a L2 product, that is a level 2 product, is available, you should download it first. Okay, you should give it preference over the level 1 product. So once you select this level 2 data, on the bottom you can see the option for a time range, and in this time range select the time from which you want to download the data. For example, maybe if I'm looking for data from let's say 1st of April 2026. So oh sorry, 1st of April 2025. So I selected here, and this is the today's date. By default, the until is the today's date. You can change this until, and you can choose any particular date. So for example, if we choose in 2025 until December, so I chose 31st December 2025. Simply now click on the search button. So it will take a little time to search the data, depends on your bandwidth and also the server speed. Let us give it a moment. So once the data is loaded in this frame here, it will show the footprint of the images that is available to us. Okay, so as you see, there is this one footprint in which the complete area is covered. So we have to look if there is cloud cover in that area or not. Or what we can do is we can download two different images and then we can merge to that, right? So we will be doing the merging also in one another exercise. For now, we'll simply download one data. So on the left, if you see in this imagery boxes, there are some images which have cloud cover on it. So if it is very white, you can visualize that they have a very dense cloud cover. So it is not advisable to use the imagery with cloud cover, as it will not be useful for your analysis. So what you can do is look for the data that has no cloud cover. Okay, so for example, if I look at this image, there is this I tag here. Just simply click on it. That is the product info, and you can see it clearly here that there is no cloud cover, and it also shows you where the image boundary is. Okay, just for example, I'm showing you the image with cloud cover. So this image will not be useful to us. Okay, so just download the data without any cloud cover. Simply click on download. Once you click on download, you can see the percentage bar here. The data will be downloaded first to your browser and then to your file. So first it has to complete to 100% here, then you can then it will be directly saved to your computer. So once the data is downloaded, okay, one more thing, if for all the people who are attending this session live, if you come across any doubts, you can ask me in the live section, or if you want me to repeat something, we can do that also. Okay, now once the data is downloaded, it will be a zip file. So once the data from the Sentinel-2 is downloaded, it will be a zip file. You need to extract that file, and once you extract, it has a subfolder. So the big name here represents the dates from which date range the data has been selected. Okay, S2 means the Sentinel-2. All of these items that are written here, they have some kind of meaning for the data. So when you go inside this data, you will find 4 folders here. In this folder, the folder for us which is important is the granule folder. Once you click on the granule folder, you will find a further folder that is L2A. You again open it. So I will repeat this part. Go into your Sentinel-2 data, enter this folder. You will find a folder called as granule. Enter the granule folder, and in this folder you will find L2A. Open this folder, and there you will find the folder of image data. In image data, you will find the different resolutions folder. So the bands which have the resolution 10 meter are available in this folder. The bands with the resolution 20 meter are available in this folder, and similarly the bands with the resolution 60 meter are available in this folder. So if you see, if you remember from our previous sessions, the Sentinel-2 has 12 bands, right? And most of them, as you can see here, some of them have the 10 meter resolution, and some of them have the 20 meter resolution, and one or two, three bands of them have 60 meter resolution, right? Now, once your data is downloaded, the next thing you need to do is, because we are going to work with semi classification plugin, we need to understand about it. Okay. So in QGIS, there is an option for plugins, and and we will install one new plugin that is called SCP. I have already installed it. If you can see, there is this option here, SCP. So just simply go to the plugin section, click on manage and install plugin. In the plugin section, just click on manage and install plugin. Here you will find a search bar at the top. You need to write the word semi. So just by writing down semi, you might find in the search field that there is this semi-automatic classification plugin. Now just click on it. Because I have already installed it, you will find a reinstall plugin button here, but if you are installing it for the first time, you will have the reinstall plugin here. Okay, so simply click on the install. It will take might be a minute for you to install it. Once you install it, you have to close your QGIS and again open your QGIS. If the SCP after opening again the QGIS is available to you, then it is good. Otherwise, we need to do one extra step to install it. So I would like to say it again. There is two parts of installation of SCP plugin. One is simply going to plugin and just looking for the name of it and install it. Now the second part is you need to go to Google. In Google, just write semi-automatic classification plugin. Just search the plugin's name. Once you search it, you will find there is a tab that says about the introduction, which is on the official website of this plugin. If you see this one, introduction, just simply click on it. And in this, you will find on the left the second point, that is the plugin installation. Click on this plugin installation. By the way, if you want to read more about how this plugin was created, who created it, this website is the one that belongs to this plugin, right? Now, as a QGIS user, I would say this is a very powerful plugin. It has all the capabilities to do the supervised as well as unsupervised classification, and there are also some developer tools you can work with it. Okay, now you will find 2.1.2 here, installation of required dependencies. So just click on it simply and scroll a little down. You will find this black screenshot under which there is this enter the following command. Now, because as I said, once you open your QGIS and if this SCP is not available, so you have to do this second part of the installation. Now what you need to do is simply look in your computer for OSGeo 4W. So just copy this and search up for this in your computer. So there is this OSGeo4W shell. Click on it. So a screen will open just like a command prompt. In this screen, you have to copy this pip3 install upgrade remote your sensors. You need to copy this and you need to paste it here. So our computer was missing one of the libraries to make that SCP plugin functional, and to make it functional now we need to install this second part. Okay, now simply click enter. It will take a little time, around 2 to 5 minutes, and after that you will get a message successfully installed, right? So just install this one. I will again just give a brief that simply look for the semi-automatic classification plugin. Go to the introduction website of this plugin. Look for the plugin installation tab on the left. Here look for 2.1.2 installation of required dependencies. Click on it. So the Sentinel data that we earlier clicked to download, now it has been downloaded to our computer. Now here just look for this pip3 install. Open your OSGeo4W shell. It will look like this. Enter this command and press enter. Okay. So once it is installed, you again need to close your QGIS. So just simply close your QGIS and then again open your QGIS, right? The SCP should appear here. Now let me make you familiar with this SCP plugin. So simply if I click on it, there is an option that is called as band set. Now if you click on it, this is the interface of SCP plugin. All the possible functions that it has, they are here on the left. So you can do some scripting in here. You can use the band calculator, which is very similar to the raster calculator in the inbuilt QGIS. Then we have something called as post-processing, band processing, processing toolbox. So most of the functionalities available here we have covered in our theory classes. Okay. So there are some basic tools. If you want to download product directly from Sentinel and Landsat data, there is an option that is called as download products. What you have to do is you need to simply log in with your USGS Earth Explorer login as well as your Copernicus Data Explorer login. Simply enter it and then you can search the date range and you can directly download the data here. In the bottom you can see the number of bands which you want to download. Okay. Now we are going to work with the SCP classification now. What you have to do is to load the data. First we have to sort the data. So if you go back to the folder, that is this 10 meter resolution, 20 meter resolution. Now what I want you to do is I want you to create a new folder in your computer, an empty folder in your computer. So for example, I created this one folder, that is S2 demo. Create one empty folder. Now from these three resolutions, we need to copy band wise from 1 to 8 or 9, whichever bands we are going to use. So just go to the first one. For example, if you see, the band name is mentioned here. In the letter part of the name, the band name is mentioned here. This is band 2, band 4, band 3, band 8. So I am able to see band 2 here, band 4 here, band 3 here, band 8 here. Copy the additional files also. So I will just copy it and put it in my folder. Then I'll go back and then I'll look in the 20 meter. So if you see here, band 1 is missing. There was no band 1 in 10 meter resolution. So I will look for this band 1 in this 20 meter. Now I have this band 1 here. I'll copy this to this folder. And now I have, if I sort it, I have the band 1, 2, 3, 4. So 5, 6 and 7 are missing. So I will locate here. So I just have 5. Okay, I have 5, 6 and 7 here. So I will copy to it. Okay. So as you can see, I have all the bands from 1 to 8. If you need to do like for our current session, we just need 8 bands. So I'm loading just 8 bands. You can load all the bands. So you can load the 9, 10, 11, 12 also. Now simply go to your SCP plugin. That is here. Click on this SCP plugin. Click on band set. So this interface will open. On the right side, you will find this green bookmark. Just simply, this is the browser panel. Just simply click on it and access to your folder that you just created. Now, first you need to sort it. Sort by name. Okay. Select the bands and open it in your. So if you see now, the bands have loaded here. You need them in the correct sorting order. You need them like 1, 2, 3. Okay. Now why this sorting order is necessary, I will explain. Once you add the data, because we are working with Sentinel-2, you will see on the bottom there is something called as wavelength. In this wavelength, there is an option of band order. So if you click on this, there are different possible satellite options here. So since we are working with Sentinel-2, we will click on Sentinel-2 here. The order is stated here. So the data that you have opened here should be in the order that is given here. So now it is in the order 1, 2, 3 to 8, right? If you have to add further data, just don't get confused with 8A. First you need to import 8 and then 8A, then the 9, 10, 11 and 12. So if you are working with Landsat, the option is here, Landsat 8 OLI. So if you are working with Landsat 9, right? If you are working with Sentinel-3, you have different satellite possibilities here. Now, once I click on this, what will happen is, if you see this center wavelength right here, once I click on Sentinel-2, it will load the actual wavelength here. So this is important for our analysis. Now, sometimes what happens is, we are working with some kind of drone imagery. Now, for drone imagery, there is no inbuilt option here. What you have to do is, you need to simply click on band order then, and then you have to manually add the wavelength. So if you are working with some drone data, don't forget to manually add the wavelength. So I select Sentinel-2 here. Now there is another option here, that is this band set table on the left. Now this is one, if you see by definition, this is one set of bands. Okay. Now if I want to work with multiple combination of set of bands, what I can do is, I can simply click on this add new band set, and this will add a new band set here, and I can load another set of imagery here. Okay. So you can work with multiple band sets in SCP plugin. Now I don't for our current session, I don't want another band set. What I will do is, I will delete this one. But if you are working in multiple, if you have to work with multiple band sets, now you know how to do it. So simply click this and delete. right? So once your data is uploaded to your semi-automatic classification plugin, you will see that after installation of this plugin, this toolbar appears in your QGIS. If you look at my last toolbar, this one, I hope you are following my cursor. This toolbar is associated with the SCP plugin. Now, once you install SCP, this will appear in your QGIS. You will find on the left, there are, if you see these gray things on this toolbar, this is the, like, it is the breaking title. So every option that is on the right of this, it belongs to the options of preview. Everything on the right of ROI, this is ROI options. So this is RGB options. So we will understand what these buttons actually mean. So first, if you see on the left side, RGB. Now, since we have already added the data to our SCP plugin, now in RGB, what I'm gonna do is, I will open the combination of bands. So this is the band stacking. That is the stacking of 3 bands. So for example, if I open 432, so I can get a true color image, right? So this is the true color image of the area. Now, what if I want to open a false color image? So what if you look in the Sentinel-2 bands, so NIR is 8, red is 4, green is 3. What I can do is select NIR, then red and then green. So I will make a combination of 8, 4, 3 to create a FCC image, that is false color image. So let me change it to 8, 4 and 3. Once you enter this 8, 4 and 3, simply press enter. So the area has changed into a false color image. Now we have seen the true color image as well as the false color image here now. So just change it back to the true color image, that is 4, 3 and 2. Now the next step is to actually assign signatures. So if first we are going to do the supervised classification. To create a supervised classification, we have to give some signature samples, and those samples we have to assign them a name. Like if we have to pick some signature samples from this image, as you can visualize, this area belongs to built up. So we will pick up some samples from here, some sample pixels from here. So those samples, in the terminology in GIS, they are called as training samples, because we will train them, we will train this inbuilt algorithm. We will tell it that the values, the digital numbers that belong to this built up here is what you have to locate in the rest of imagery. So you have to locate the built up in the rest of the imagery. So based on this signature sample, it will look for the buildings in another areas, right? So I will, for example, if I give some farmland signatures, so based on these signatures, it in the complete image, it will classify whether it is a agriculture land or not. Okay. So the next thing that we do is, you click on the right in this empty place on the top, just click, and there you will find SCP doc panel. So this is also associated with SCP and it is important for doing the classification. Simply click on it and it will appear here. Okay, so just make some settings, make it get attached somewhere, right? Now in SCP doc, there is this option on the left that is called as training input. Simply click on the training input, right? Simply click on the training input. Now we are going to select some sample pixels. Before selecting, we need to save the file, and if you see, there is this option that says create a new training input. Click on it, save the file in your computer. So once the file is saved, you can see the location of that file here. Okay. Now, for example, I can visualize this built up area, right? So I need to go to this option on my SCP toolbar. If you see here, it's a create a ROI polygon. Okay. Simply click on it. Now I can select my sample pixels here. For example, if I select this area, because I know that it is built up, so I right click and it will end the polygon. So this is one sample. If you want to remove this, once you okay, I'll show that step in the next part. Now, as I have taken this built up area, what I can do is, on the left here you will find two options, that is macro ID and class ID. Macro ID means the overall ID. For example, it is a built up area. In class ID, you can define a sub class. For example, I can call it as a village built up area, or a city built up area, or maybe residential area. It depends what kind of analysis you are doing, and based on that you have to give it the name. So for example, now let us call the macro ID as built up area, and the class name as city built up. So because these are the first signatures that we are going to add, we have the macro ID as serial number 1 and the class ID as serial number 1. Simply click on this button to save these sample pixels. So if you click on it, you can see the processing. It should not generally take so much time. Yeah, so it is saved here, right? Now you can change the area, you can change the color of it in front of the color section. Just simply click here. Maybe I want to represent the built up as light blue. Okay, and city built up as, I would give it some similar color only. Okay, now if the next step, we have one class, that is the built up class. For example, now I want to add the agriculture land. So what I can do is find a good training area for agriculture land, right? So for example, in agriculture, I am seeing that there are multiple shades, right? So we will define a different class. So let me choose this one area. So I will again click on this ROI button, select the area, call it as the agriculture land. So it is full grown agriculture land. I will save it. Now if you see, there is water also here in the canals. You can see the water. uh, One mistake that we did there was, because we chose the macro ID as one only, it got clubbed into agriculture. Now to undo the mistake, there is this option here on the left. If you see, I will simply click on it and it will delete my last created signature. Okay, so I will again create the agriculture land. So let me this time change the class of both of them to 2 and 2, because if you keep it as 1, it will get merged into the built up area. So if I save now, okay, now the next step is, we have two classes already, agriculture as built up area. So change the color of agriculture to dark green maybe if you want, and in full grown you can choose the light green. So now we need to locate the areas which has water. So for example, I see a canal here. So that can be classified as water, and the subclass can be canal, right? Change both to 3 and save. Now if you see, I saved one class of water. Now I find another subclass, that is the river water. So this is a river going here. I want to classify this also, but I've already created a macro class, that is water. What I can do now is, again if I want to give sample, I will click here. This time I will keep the macro ID as water only, and I will change the class ID. I will, because it already gets to 4, that is we have already 3, so it turns out to be 4, and I will call it as river. So this time if I add, it will be added into the water class only. Okay, now we already have 3 classes built up: agriculture, water. Now we have barren land also seen here. This is agriculture barren land, as well as we have normal barren land. But mostly in this image we have the agriculture barren land. So we will also create this pixel of barren land also. So just select a good training sample. For example here. Now other than this normal ROI option which that we were using before, this ROI polygon is based on selecting pixels. Now it is pixel based selection. We create a polygon and all the polygons inside of it gets selected. Just to the adjacent of it, we have a activate ROI pointer. If you select this, what it does is, it has an object like similarity. What it means is, once you use this, for example, when I click this and I click anywhere, if I want to create, look for some samples here, it will automatically find pixels that are alike. So it gives a shape by itself. Okay. So if I click here, it will say select these pixels. Now there are options to change how this selection is done. You can change the distance, you can increase the number of pixels. Like for now it is selecting 100 pixels. Maybe you can make it just 50 pixels. So if I click now, it will select 50. Okay, that was nearby, so it will just select 50 pixels. So I've changed the minimum to 40 and maximum to 50. Right. There is also the classification based on distance. So you can change this part also. Now, we are taking this sample for the barren agriculture land. Now the macro class that we have here is agriculture, we already have. So just change it to 2 and agriculture will appear here. That is agriculture. Now this is a new subclass, that is 5. You can call it as a barren land. Right? And simply click on save. So the barren land is here. You can change its color to. So I have taken some samples. These are very few samples. If you are doing it for some research purpose or some accuracy analysis, you need to take much more samples. So for example, if I want to take again more samples of the built up area, what you can do is simply just go here, select some pixels. So for example, this area got selected and choose the class ID again. Here I will choose 1 as and 1. So these pixels will be added to the samples in this 1 and 1. Right? So you need to find as many as samples possible. This is important for more accuracy of your results. For our current session, we will just for the need to just showcase how it works, I'm just taking very few samples. If you the mark of a good GIS analyst is he will take as many as samples possible. Okay. Now the next thing is, once you have taken the samples, it got already saved. Now go back to your SCP plugin and here you will find something called as band processing. Click on this band processing and there is these two options that is called as classification and clustering. If you are aiming to do supervised classification, you have to select this first option, that is classification. If you are aiming to do unsupervised classification, you have to go for the clustering. So let us first try the supervised classification. If I double click on it, you will find the different algorithms here. So for example, already by default that has been selected is maximum likelihood. Then we have the minimum distance here. Then we have multi-layer perception. Then we have random forest. Then we have spectral angle mapping. Then we have support vector machine. We have discussed all about these theorems in our theory class. Okay. So select, for example, for our current session, let us try with minimum distance. Okay. Now there is this one important option, that is for training sample, what do you want to use? The macro class ID or the class ID? Okay. So either macro class ID or the class ID. So the samples that you took here, your classification can be either based on these three things that you took or these subclasses. Okay. So because the number of subclasses is more than the macro class, the classification based on the subclass will be much more accurate. But let us do both samples. So once if you select this macro class, right, if you want to see the preview of your classification, how it will look, there is this preview tab. Okay, so how much pixels do you want to see in your preview? You can set from here. For now, let us work with 200 pixels to preview. Simply click on this button, that is activate classification preview pointer. Once you simply click and look for any space in this image, and for example if I click here, so it has classified this region, right? Because I have taken very few samples, you can see the discrepancy that I am getting here. So some of the areas have been classified as water, which is actually maybe not water. Okay, so because the sample of water that we took was black, right, so it has also taken these black shadows as water. So you need to create another class that calling it, taking the samples from here, call it as shadow, so that your water and shadows do not get mixed. You have to create as much as classes possible. So for example, if I do an analysis, if I do a preview here, so you can see this is the agriculture land and this is the built up land, right? Now let me change the training sample from macro class ID to class ID. So if I do this, now for the same area, if I click on refresh, because this time it was based on the macro class ID, you can see the difference, right? So just below it is the built up area. It has been classified so accurately. So barren land also has been classified. So if you see, this was the river. Okay, it has classified the river also. Okay. If anyone has any doubts, you can ask me in the live chat. Now we have taken few classes here, that is for normal classes we have taken 5 classes, for macro ID we have taken 3 classes. So it depends on you how many classes you actually want to take, right? So let us try to do a classification of this complete image now. It will take a little time. So once I select this algorithm and the training class, I just have to simply first click on run. If I click on run, it will ask me to save the file. So let me call it supervised classification result. And once you click save, and go back to your QGIS, you will see the process has started. It will take a little time. So this is the final classification result of our image for our supervised classification. You can see the built up area here, right? So it has been so accurately generated. So all the small barren lands, they have been accurately classified. Okay, so this is how actually supervised classification works. Now the next we are going to do is unsupervised classification. If you go back to your SCP plugin, and go to clustering. So this time I'm going to choose clustering. In this clustering, you will find an option of k-means. In older versions of QGIS, you had the two options, that is k-means and isodata. So you had two different options for the unsupervised classification, but for now in the new uh, update we just have the k-means. So in k-means there is this different options of seed signature. Now, because in unsupervised classification we do not give any training samples, the training samples are based only in the supervised classification, whereas in unsupervised classification the computer itself, using some algorithms, that is for example k-means, isodata, using these algorithms it decides how to create the class. Now here we get this one option, that is the number of classes. How many classes we want? We can have 5 classes, we can have 6 classes. So based on our input of the classification, the computer will create the classes. So let us choose number of classes as 8. Okay. Now if I simply click on run, first I will get the option to save this data. Let me call it as unsupervised and save. So you can see the process being happening here. So it will take a minute or two to complete this unsupervised classification. So here we have our unsuper classified image. Okay, there might be some errors because of which algorithm we selected, right? You can see I can see that there are some kind of errors, but because it has chosen the colors which are very similar, we are unable to differentiate in among the colors, though there are 8 classes. What you can do is you can simply go here and change the colors, and then you will be able to visualize it better. So for example, for this, if we choose a blue, for this green, for these green, maybe yellow, for this red, for this purple, so we have so if I apply now, you can see the difference. But as I say, it also depends on the algorithm that you have used. Now there is k-means. Look for a plugin, look for a version where you can find the ISO data, or try to change some options here. Maybe try with spectral angle mapping, maybe change the seeds to use signature list as seed signatures. So there will be a difference in the results, but for sure a supervised classification is always better for a image. So if you see in this supervised classification where we as a human gave the input, the result was so much better. Now, one other advantage of this SCP plugin is that you can also create, as in our last class I explained about the spatial indices, you can also use this plugin to actually evaluate those indices. So for example, if I go back to this SCP plugin, you will find an option here that is called as band calculator. So if I click on band calculator and if I click on this refresh, the bands will load from my library. Now, because the band has some metadata, it repeats here twice, but look for the band number in the last. So if you remember the formula for ND, if you go in this function section here, if you remember the formula of the NDVI, you can write it here. Otherwise, if you go to this function section, just look for NDVI here in the indices, double click it and the formula will appear for you. Okay, now based on the formula we will select the bands. So if you know that NIR is band 8 and red is band 4, so select NIR, click on band 8, then select red, then select band 4, then again select band 8 and then select band 4. Okay, now simply click on run. It will ask you to save the file. You can call it as NDVI and save it to your computer. So the process is running. So we have your NDVI product here. Now simply click on the right click on it and go to the properties and choose symbology. In symbology, choose single band pseudo color. Give it the colors as per your requirement. You can change the values of these colors here. Okay, now simply click apply and you will be able to find the symbology intervals classify 6, apply. Okay, so you will be able to understand your image for NDVI also. Similarly, you can calculate all the other indices. You can calculate NDWI. So this SCP plugin is very useful to us. In some other sessions, we will also try to understand what is PCA analysis. We have here RGB composite. We have many options here. So just try to explore this. We have the option to change the classification, because our classification result is a raster, right? So we can convert it into a vector. You can download the classification report. You can create the accuracy analysis. So there are multiple options here to explore. Okay, so if anyone has any doubt, just let me know. Otherwise, we will end this session and we'll see each other in the next session. Okay then, thank you for attending the session. I hope you had a great learning experience. Let us meet in the next session. Thank you.